Hello everybody, welcome back to another episode. In today's episode, we're going to be covering a topic that I feel like a lot of people have trouble with, which is inequalities. So, inequalities kind of are a counterpart to the equal sign in a way. And let me explain exactly what I mean. So, if we have the relationship x plus 2 is equal to 5, then we know that the left-hand side here and the right-hand side are equal. This equal sign, and let's do this instead. This equal sign here in the middle is a relationship between the two halves, the half on the left and the half on the right. It's telling us how they're related to one another. So if we swap out the equal sign now for a different sign, this symbol is just going to tell us the same thing. It's going to tell us a relationship. However, that relationship will be slightly different. For example, what this symbol here means is that the 5 is greater than x plus 2. Oops, wrong color. X plus 2. So we're restricting what we're allowed to have on that side. And now instead of one answer being correct, we have an infinite number of answers being correct. But we have to decide where it is no longer correct. So, for example, we know whenever x plus 2 is equal to 5, then 5 is no longer greater than x plus 2. In this case, if we were to solve the original equation up here, x plus 2 equals 5, we would find, after subtracting the 2 across, x is equal to 3. So as long as x stays smaller than 3, then our inequality x plus 2 will be less than 5. So that's the stipulation here. X has to be smaller than 3, and then this inequality will stay true. And we can draw that on a number line as well, and show interval notation to express this. The interval notation is just a way to show what our answer is allowed to be. Let's go ahead and show this on a number line first though. I'm going to clean up some of this. Yeah, let's clean this part up. And then we'll move this over. So if we are going to draw a number line here. Sorry, that was awful, but it's okay, we can adjust it slightly. So if we draw this number line and we throw 0 here, and then 1, 2, 3, we know x has to be smaller than 3, which means it is allowed to be every single value less than 3. And how we're going to notate this, there we go, is that there is this open circle here at 3. Let me go ahead and write in the negative values. So at 3, we're going to have this open circle, and then we're going to have a line which goes this way. So 3 is not included because it is this open circle. However, everything to the left of 3 is included. So this is how we would start graphing it. If, for example, our restriction was x has to be greater than 2, then, let me go ahead and erase this. Oops. There we go. Then we would have an open circle at 2, since it has to be greater than 2, and it would be going to the right, because it's allowed to be every value larger than 2. Let's go ahead and look at a couple more equations which might highlight this. I'm going to go ahead and get rid of this number line, and yeah, let's go ahead and get rid of this as well. So if we were to have an inequality such as 2x must be larger than 4, then we can divide the 2 across, kind of like normal algebra, and see that x must be larger than 2. And again, we'll go ahead and draw our number line. We're going to put 0 here, 1, 2, 3, 4. Again, open hole here, and then going to the right, because it's allowed to be anything larger than 2. So what happens now if we flip this just a little bit? So we're going to introduce 2 more signs. And first, let's go ahead and actually name these. So we have these 2 signs, and you always read from left to right. So here we would say x is smaller than 2, or less than. So this is our less than symbol. Here we would say x is larger than 2. So this is our greater than symbol. Now we can combine our equals sign and one of these 2 symbols as well. And what that looks like, is this. So we have our symbol and then a line beneath it. And this means that it's also allowed to be equal to that number. So this is less than or equal to, and this is greater than or equal to. So if, for example, we take one of those equations that we had been playing with earlier, let me move this over so I can erase it all. If we were playing with one of those equations from earlier, let's go ahead and do 2x is greater than or equal to 4. Now, x, after dividing 2 again, will be greater than or equal to 2. And when we do this on our number lines, we change, sure, that looks awful, I apologize. We change from having an open circle to a closed circle. So the closed circle symbolizes that 2 is included in the values that x can be. Sorry, I can't draw. There we go. So 2 is allowed to be included in the values that x can be. So x can be 2 or anything greater than 2. Let's go ahead and erase this now. There are some instances where this can become, I feel like inequalities, at least what I have explained to you so far, is okay. And then we start explaining a little bit more complicated ideas, and I feel like that is when students begin to get confused. So I'm going to show you one of the things that students oftentimes get confused with, and that is, what if we have a negative? If we have a negative here, right, 3 is larger than negative 2. Negative you can think of as being in debt, right? So if you owe money, you're always going to have less money than if you actually have the money in your pocket. But if we are to multiply by a negative 1, for example, and this will come up naturally in problems, and I'll show you an example, we have to flip the sign the other way. So if we multiply both sides by negative 1, let me multiply both sides by negative 1, which is all this notation is, then we get 2 is larger than negative 3. And this is also true, but it's not the same statement as before. 2 is a positive number, and positive numbers are always going to be greater than negative numbers. If we have negative 3 and negative 4, negative 3 is actually a larger number because we owe less. We're less in debt. Sometimes people get confused with this because they see a 4 and they're like, well, 4 is larger than 3, but not when you owe it. If you owe 4, then you owe more. Okay, now let's go ahead and look at an example of this in a problem. If we have negative 3x, which is greater than 6, well, we're going to first divide out this negative 3 from both sides. But because we're dividing by a negative here, we need to flip the sign. X will be smaller than negative 2. And the intuition's the same as what I had said before. Because we're making this x here multiply against the negative 3, we kind of have to flip it around in our heads. So x has to be smaller than negative 2. Again, if we graph this or put it on a number line, then we see at negative 2 we have a hole, and x is allowed to be anything smaller than that. So knowing this, if we say x is equal to negative 3, for example, and we plug that back into our initial inequality, we see negative 3 times negative 3 is 9. And 9 is going to be greater than 6. And then again for the second inequality, here, we see that negative 3 is in fact smaller than negative 2. So it works out both ways, and oftentimes it has to do with multiplying a negative and a negative, which ends up being greater than the positive number. But this is something that people struggle with a lot of the times. And just remember, you're just flipping your sign. You're just making it go opposite directions. The same thing is true if you have a greater than or equal to sign, or less than or equal to sign. So, for example, if we have 4x is greater than or equal to negative 8. Let's change this slightly, just because this actually doesn't work. Like this. Negative 4x is greater than or equal to 8. Well, we're going to first divide by a negative 4 on both sides. And then we get x is smaller than or equal to negative 2. Okay, so anytime x is less than negative 2 or equal to negative 2, then negative 4 times x will be greater than or equal to 8. So for example, if x is equal to negative 2, then negative 4 times negative 2 is 8. If it's negative 3, then we see it's 12. So again, we're multiplying those two negatives, which will give us a positive value, because a negative times a negative is a positive value. Let's go ahead and delete that. Okay, so far we've talked about what the inequality signs are, displaying them on a number line, and solving for a negative value, or dividing by a negative value, or multiplying by one as well, and having to flip the sign with that. Now let's go ahead and talk about compound inequalities. So we're going to restrict our values specifically to a known interval here. And the way we do that is by using two inequalities. If we have x, and let's go ahead and restrict it between these two numbers. We know x is going to be larger than 2, but equal to or smaller than 5. So we end up with this interval of values that x is allowed to be. And let's make these arrows actually. So if we have 0, 1, 2, 3, 4, and 5, x has to be greater than 2, so we have that open circle here, but equal to or less than 5, so we have that closed circle here. So now we have this interval of values that x is allowed to be. And this brings me, let's do one more example and then I'll explain interval notation, which is a way to express this in a different manner. So if we now have, and we always do the smaller number on the left and then the bigger number on the right, that's just convention here for these type of problems. If we have x in the middle again, and let's say it is greater than -4 but less than 0. Okay, so we're going to make our number line. We're going to put 0 near the right since it's our largest number we're dealing with, and then we're going to put -4 to the left since it's the smallest number we're dealing with, and then 1, 2, 3. -1, -2, -3. So again, we're going to start by placing our circles on our points, so we know it is going to be greater than or equal to -4, but less than 0. So we have a closed circle on the -4 and an open circle on the 0. And now we're just going to connect these two together. So these are all the values that x is allowed to be to fulfill this inequality here. It can be -4 and anything between -4 and 0, but it cannot be 0. Okay, now let's go ahead and talk about interval notation just slightly. So whenever we have an inequality like this or like this, greater than or less than, we say these are open because we're never going to actually be at that point. So for example, if we do examples like this, x is smaller than 2, x can never be 2. It has to always approach 2 but never actually get to 2. And then same for x is larger than 3. X is larger than 3, but it's never actually 3. It will never be 3. So these are known as open, whereas, and it goes with the circle as well, right? Because this is an open circle. However, if we have an equals inequality, we say this is closed. And let's do the same two examples. So here, x is everything smaller than 2 and 2. So it's going to be 2 and everything smaller than 2 as well. And then for 3, we see x is everything greater than 3 and it's also 3. So this is closed. And let's go ahead and show you again. That is why these circles are closed circles, to go with that naming convention. So now that we know what closed and open inequalities are, let's go ahead and look at intervals. So the interval is kind of like what I was showing you earlier, where it's bound between two values. And we can actually say that it's bound by infinity as well. So if we have x is greater than 2, our upper bound here is infinity while our lower bound is 2. So it's never going to be 2, and it's never actually going to be infinity. It's always going to approach infinity, but it's never going to be infinity. So we can write this as two numbers with parentheses around them. Parentheses indicate open, whereas brackets would indicate closed. And let me show you an example for a closed interval. If we have something like this, where x is some number between 2 and 5, but it can also be 2 and 5. Again, this is a closed inequality, and we would also call this a closed interval because both sides are closed. Now we use a bracket to show this. Sorry. So we have bracket 2 comma 5 bracket, and this shows that it's closed on both sides. We can also have half open, half closed brackets or intervals. So for example, if we have x is equal to or larger than 2, then this here would end up becoming a bracket. And for the other one, if we had x is larger than or equal to 2 but smaller than 5, and we get rid of that equal sign, we would make this right side a parenthesis, which is the same as the other thing that I did. But we could do it for both sides. So if we make this equal, and then make the 2 smaller than, we would change the other side now into a parenthesis like this. So this is just very basic introduction to inequalities, and interval notation as well. I will have another video on interval notation in the future, so look forward to that. But I just wanted to introduce it a little bit and give you guys a little bit of understanding for these concepts. These concepts can be kind of hard to grasp sometimes, but I hope this helped, and I hope this was able to clear some things up, maybe see some visuals, and understand inequalities a little bit better. Thank you guys so much for watching. Stay tuned for more episodes, and subscribe if you're enjoying this series so far. Thank you.